Pick a number between 1 and 10, say 5.6. We know, with our number system, multiplying this number by 10 moves each digit to the left relative to the decimal place. Multiplying by 10 again moves it all again to the left, whilst dividing by 10 moves it all to the right relative to the decimal place. If we multiply this number by 10 many times, it can become inefficient to represent it by its digits and with their place values. For example, writing 5.6 billion in this way involves having to write 8 zeros, which is just a bit tedious. Instead, we may choose to represent it by saying which number between 1 and 10 it corresponds to, and how many times do we have to jump to the left or to the right to get the correct number. Each jump to the left means multiplying by 10, and so we would write 5.6 billion as 5.6 times 9 lots of 10, each corresponding to a jump, which we write as 10 to the power of 9. This is called writing 5.6 billion in standard form. We can do the same for really small numbers. For example, the size of an atom in meters could be given by this number. Writing all these zeros is tedious, and we instead indicate that the corresponding number between 1 and 10 is 1.2, and that we need to jump 10 times to the right from there. This corresponds to dividing by 10 10 times, or dividing by 10 to the power of 10. Dividing by 10 to the power of 10 is the same as multiplying by 1 over 10 to the 10, or 10 to the power of minus 10, thanks to this rule of indices. And so the standard form representation of this number is 1.2 times 10 to the power of minus 10.